All right, so this one's working now, my man, and I see chat. So post that one and see if some people show up.
Okay, I'm jumping off the phone now.
Okay, see you. All right, hit me on chat. Let me see if I can see chat now that I had to teach Jay how to run YouTube live streaming. All right, Jay says no. Are we doing this live? Hell yeah, we're doing this live. It should be a good time, right? All right, we got bored. Everybody's in. I assume I got extremely well roasted, so hopefully you guys did a good job roasting me. If not, continue roasting in the chat. It'll be fun. I think we can do our intro lab. And really, I just wanted you guys to get some experience seeing all the cool stuff going. I managed to go steal an air compressor from somewhere. I got some power going. I'll let you guys start filtering in. I see about 13, 14 of you going. We've got valves, we got cylinders, we got all kinds. I think at first, we'll just try to get a valve going. So I showed you guys, hopefully everybody watched the video from the other night. We've got wires that come out of said valve, out of the connection, and then we've got, that's our electrical or our control with the valve, and then we're gonna fire up some air and get this bad boy going and see if we can do something. You guys wanna do single acting cylinder first or double? Give me a quick vote. Single or double, what do we want? The chat has died down. Double, single, all right. We'll go double, it'll be fun. All right, so first thing we're gonna do is we make sure we actually still have shop air. If you guys can see the regulator back here I was talking about before, what do you guys see for our current shop air? What do you see in PSI? You can't see anything because it's too far away, right? Right now I've got things set at about 80. We'll see how our cylinders and valves do. Most shop air is somewhere between 80 and 100, 100, 110 in some of the better shops. All right, so which one of these cylinders, top or bottom, is the single and which one's the double? You guys want to do double, single? What do you want? You want to do double? Okay, which one's the double? Is it the top or the bottom one? Absolutely. All right, so we're going to put that bad boy on here and try to get him to actually do something. Is that too low? You guys can see it? All right, that's good. All right. Let's get that sucker on. All right, let's see what we got going with our valve. Is that even remotely readable? What kind of valve is that? Is that your 5.2, 5.3? What is it? Anybody know? Let's look at it again. What were these things called? You guys remember from the video from before? It's called almost drop it and smash the camera. That's what it's called. All right, most of you seem to think it's a 5.2. What do you guys think these little things are? Let's go on and get that sucker set up. All right. The first thing we should probably do is get power to our board. So we're going to give ourselves a little ground and a little power. We're not going to turn anything on. How do we get these two connected? I don't know if you guys saw before, but we've got lines that connect from each side. So we'll set ourselves up so we got ground all the way across our rail. And then we're going to attempt, that's right, jumpers. Whoever said that, good job. We'll throw those suckers out to the side. All right, there we go. We're going to want to use a switch to try to turn this sucker on and off and make sure we can get the valve to do something. So what have I got there? Which one's the ground? Which one's the control? Just give me a color. Hopefully you can kind of see what I just did. What did I just put this wire to? Where is it going up there? There's all the cables, sweet. All right, if I wanted to give power to this, what do I put on the top side of the switch? Where do I take it? Let's give it some power. All right. We're going to give our board some power and see if we can get anything to work at all. We've got about 18 volts DC. Is that good or bad? I like the boom, exactly. All right, if I hit this switch, what should happen right now? I got power to the top side of the switch. It's a normally open switch. I got ground to the bottom and it's going through my control cable to my valve. What should happen if I hit this switch? Valve should come on. Which side came on? Did I connect 1 to 2 or 1 to 4? Hell, I got no idea, right? So the next thing we're going to do is we're going to kill our power for a minute. We're going to make sure we got air. We're going to hold this hose and we're going to have our safety glasses on. Let's see if we got any air. Hey, that's good. It's not the trick hose that Brandon used to put in for everybody. Which side of the valve do I put this into? Where do I put supply? Do I put it into 1, 2, or 4? I got 1 down here. I got 2 and 4 on the top. Anybody want to guess? 1, 2, or 4? Am I still going or did I freeze up? 1 with a question mark. We can try that, right? Let's just see what happens. Now, remember the connectors that I showed you guys before. Hopefully everybody saw a video. To get into there, I've got to take the hose and push it in, then I get a connection. So what should happen right now is if I turn on the air to this valve, should I get anything out of these 2 ports? Yes or no? One of them's already open. Is that good or bad? Right now, port 2 is open. Is that what was supposed to happen with that valve? I got supply into 1 and you can't hear me because the compressor is going in the background, right? How do I get that to stop? Right now, air is coming out the side, right? I'm going to see if I can plug it. Let's see if that does anything. No bueno. Love it. Let's see what happens if I do this. Maybe it won't shoot out in my face. I got air. Hey, cool. I don't have air going everywhere, right? I got a port blocked. So what should happen if I hit the switch now? If I turn on power and I got air because I got supply to it, I got nothing coming out. If I hit the button, what should happen? It actuates, but I got nothing happening. Is that good or bad? Probably bad, right? Why don't I flip the other side and see what happens? What about now? Anything going on? Let's hit the button again and see what happens. Now I got air out the back side. That's good, right? Alright, now let's plug up some cylinders and see what happens. Apparently I gotta go find some more hoses. Jackpot, we got a bunch of hoses. I'm going to plumb one side of the cylinder to one side of the valve and the other side of the cylinder to the other side of the valve. Is that good or should I have that different? What's going to happen if I turn on the air? Nothing. Now what should happen if I hit the switch now? Nothing. Let's try the other side. How do I get it to come back? How's that? Was that pretty cool? So if I hit button 2, I should connect one side of this and get the valve to extend, or excuse me, the cylinder to extend. If I hit the other switch, I got the valve to retract. Out, back, out, back. Exciting, right? So let's go to our intro lab. Was that in D2L? I sure hope it was. It says use a spring valve to actuate a single acting cylinder by pressing a momentary contact button. You'll have to show some adaptability since you have to use a 5-port valve to control a single acting cylinder and indicate you're going to plug one port on the valve. We did that a minute ago, right? Where we plugged one side and we could switch this out for a single acting. Why don't we do that real quick and see what happens? That way we can satisfy the first part of the introductory lab. Single acting or double acting? All right, now that I have spaghetti going on, what did this line do? This line comes from our air and our manifold, that's what this is called, a manifold, over to the valve. I supply the valve with air. Now I've got 2 different ports that it could come out of, and I got to block one so I get the valve to actually operate. And I'm going to try to extend this single acting cylinder here. Which one of these 2 buttons should make that happen? Do you guys remember? Was it button 2 or button 3? Is that good? Is that doing what we think it's supposed to do? That was kind of weird, right? That extends it, but it doesn't retract when I let go of it. But it does when I do this. Why? Let's see, we wanted to extend a single active cylinder when we hit one button. So did we get that to work? Kinda. That doesn't work for some reason. That seems to be working, but it's not going back. What should I do here? I have to vent it, okay? How do I vent it? So what's going on here? How do I get this to do what I want it to do? Take one of the plugs out. I just took that plug out, right? Here I got any idea what's going on? Swap the valve outputs. You saying swap the wiring? How do we get that to stop? What do we think's going on? Any ideas? A minute ago, we had this bad boy working, and we had a double acting cylinder in there, right? That's why you wear your safety glasses. Let's try air again. So we got air pouring out of the valve, right? What if you add port 2 to the single? That's what we were doing a second ago, right? When we turn it on, air is pouring out of 4. What do we got to do? Block it again. I got to find my block. So why didn't it come back? Anybody know? I like that flying spaghetti monster. You got that right. What solutions do I have? Supposed to return on. It's not venting until you press the button, right? Needs to be solenoid spring, so we'd use the other one. Our thing suggested to block one port, right? And that doesn't seem to be working. Let's look at our valve again. Five two. What do we do? What do we think? I think we hate that valve. Let's try a different valve. Do we want our supply on 1? Actually, let's go all the way back for a minute. Let's make sure we understand what the heck's going on with our valve. So if we put supply to 1, should we get anything out of the valve right now when I turn it on? Air's pouring out of here. Let me make sure it's the same kind of valve real quick. Yep. So that means those two are connected, right? And if I hit the button between them, what's going on? I have no idea what the hell's going on. So you guys help me out here. So 1 and 4 are currently connected. Two and 3 are currently connected. Better. What's all that mean? We don't know what the hell we're doing, right? So just for fun, we'll go back to our double acting. All right, so there's our double acting cylinder. The valve needs a spring return, right? Let's do something more entertaining that we might actually be able to figure out what the hell we're doing. How about that? So we have our valve going back and forth. Why don't we create ourselves a way to set up a limit switch to use it for something else? How about that? You guys remember our limit switch from before? In the meantime, see if somebody can figure out what the heck we were doing a minute ago, because we're supposed to block a port and I have no idea what the heck is going on. There's our extended cylinder. We want to have our limit switch hit somewhere in there, so we're checking our limit. All right, we're going to kill our air. We're going to wire that sucker up. Okay, now we were supposed to use a solenoid with the limit switch. Remember, we wanted to protect the limit switch. We didn't want to put any high current to it, so we were going to use a solenoid. Do you guys remember how to wire that sucker? This was our solenoid, or actually we can use this one if you guys want to. What do we need on the top side of the solenoid? What do we got to put up there? Power, ground, control, what do we need? Top side of the solenoid needs some power, if I remember right. What do we then need to connect across? Let's see, this is where all right, we had this sucker wired up in the other video. Let's see if I can remember what the heck we did. All right, we're going to take it and we want it normally open. So that's going to go from 1 to 4. What the hell am I doing here? I want to use that as a switch to set out one of the other switches. There's that. On the other side of this ground, there's the ground. Yep, he's going to come off the switch. We're going to take ground through the switch and ground the back side of the solenoid. I think that's how we did it before. You guys agree with that? We go from ground down to ground. And then we take that to the top side of the solenoid. All right, so what did I just do there? I got ground running through the switch, so when the switch hits, what should I get here? I came out of ground, down to one side of the normally open switch, and on the other side of the normally open switch, I'm coming out to here. So if I hit the switch, what should I get there? and we'll hopefully get ground. Let's turn things on and see what happens. You guys hear the solenoid? That's good, right? Now, if I wanted to use that to allow a switch to come on, let's say, for instance, we have our double acting cylinder and button 2. Oh, we need air, right? Button 2 does nothing. Button 3 extends the cylinder. Button 2 retracts the cylinder. Extend, retract, right? Now we need to set up our other valve. Let's see if we can get the single acting cylinder to work off the other valve again. If we can, we'll move the switch down to it. All right, we want one side of this to turn on our single acting cylinder. Can you guys see it, or is it too low? No, the camera's like right up on me. Hard to see everything. We'll walk back through it in a minute once I figure out what the hell I'm doing. Is that too high or too low? Let's go right there. Yeah, that should be fine. We'll move this guy up a little bit. All right, I'm going to pull out a whole bunch of these cables and kind of start over. So there was all the control cable for this valve that we've got set up to act our double acting cylinder, all right? Now we're going to take this bad boy and attempt to figure out the single acting cylinder again, the one we were having so much trouble with. What's one key thing we've learned tonight? I should be working from a drawing right now, right? Like obviously winging it's not working. Let me see if I actually have an old drawing here somewhere. I got a schematic, but it doesn't really help me with the direct wiring. All right, so let's try again. We've got our valve wired up to our switch. We've got one side blocked. We're going to borrow our supply air from this side. What we'd really like to do if we need to get multiples of these hooked up, we'll just branch off of our line. What's one thing we could have trouble with branching multiple things off the same line? So I'm running air through a line and I'm going to pull multiple valves off of it. What could happen if multiple of those valves begin to operate at the same time, yet I've got this same size line coming in? That's right. I could have low pressure in one and not get it to do exactly what I want, right? All right, so let's look at what we got. I got air to the manifold, then I brought a supply line down and branched it off to supply air to both of my valves. I got one side blocked on one valve, and then I've still got my air plumbed to my double acting cylinder. So he should still work if I were to put my control cable back in, right? Let's see if we can get the single acting cylinder to work. Maybe somebody can throw me a lifeline as to why the heck it's not working for me. What we got here? Leaking, half flow, low pressure. I think the key is we just don't know what we're doing. I see on a 5-2, that should go straight across, and that should block to the back side. So I got a block. I got supply to 1. Is that the correct side to put it to? Somebody just found this randomly. That's awesome. Thank you for joining us. All right, let's go back. So if I were to hit this switch, I should get power to there, which should power my control valve, which I have air running to my single acting cylinder that we're attempting to get to work the way we think it is. If I turn on the air, I don't hear any air pouring out of anywhere. That's pretty good, right? If I were to hit this switch, which is connected to the valve on the left over here, let's see what happens. Hey, I get my single acting cylinder to go out, but I can't get it to come back for some reason, right? That means the air is still there and it's not coming back across. So I got to vent it somehow. Let's see if we can figure out what the heck the problem is and why it's not venting for us. Does anybody have any thoughts? Yeah, you definitely need to like and subscribe. Absolutely, right? All right, so see right now I've still got air to the single acting cylinder and I can't bring him back for some reason, right? We're not getting a vent to the backside, so air is staying there. Air right now is on 1 and 2 and it's staying there and it's not coming back. Let's swap over the control to this side. So that vented it. And that extended it. And if I had both of them going, I can supply and vent and come back. All right, that's cool. We'll let that be for now. How about that? We're now going to move our single acting cylinder. We're going to move our limit switch to use it to allow us to run the second cylinder. And then in true professor manner, what I'll do is I'll just have you guys tell me why the hell it didn't work. That can be your homework or something, right? All right, so single acting cylinder, we'll hit limit switch now. Let's see if this sucker will work. That's the one that returns it and allows it to vent. This is the one that extends, and now see it's hit our limit switch and turned our solenoid on. That's good, right? All right, so we've used the limit switch to turn on a solenoid, and we're going to use it to control something in a minute. But let's think about what the actual application is for this. So let's say I have a very large machine and I want to bring down a safety guard to protect the operator before something else can happen, right? So this might be my safety guard. I might put a proc switch or a limit switch or something there so that as the gate comes across to protect the operator, it'll then hit the switch and then allow something else to happen. Position 1 vents it. So what are you saying, swap? I'll figure that out in a minute. Let's keep going. So we're going to use that sucker to extend and make the loud compressor come on. That's going to activate this solenoid. Now what can I now use this solenoid for so that then if the single active cylinder is acting like a guard, so a guard comes across and hits a limit switch, then that allows me to make the chopper or the mover or the placer or whatever it is actually operate. So I don't want to be able to operate it until that switch comes on. So I'll then use this solenoid to activate my other switch. Does that make sense? So now I've got to get this sucker. I'm going to ground here, and then I'm going to have one side or the other be the extension or the retraction. We're going to allow the solenoid, what do you want it to do? You want it to extend or retract? I'm going to take power from the solenoid and I'm going to extend or retract the cylinder. Which one should I do? Let's think about it. The single acting is the guard. It's going to go out and hit the switch. So the actuator, the mover, the smasher, the slicer, or whatever it is, I don't want it to be able to extend unless that guard is in place and that switch is there. All right. So what I'm going to do real quick is I'm going to see which side actuates and extends. And since I'm doing this all on the fly with no drawing, like a very poor technician, I'm just going to do it via experiment. All right, so I'm going to bring power to the other side of this switch. I'm going to bring power to the other side of this bottom switch. Now I've got monster spaghetti, right? Okay. I've still got power on, everything's cool. I'm going to see which one of these extends the double acting cylinder and which one retracts it. So button 2 extended the single acting. I let off and it doesn't because we're not venting. We figured that out, but we're going to figure out how to do that in a minute. The other button vents this guy and extends. So whichever one of my controls for the valve that's on button 3 is the one that extends it. So that's the one we're then going to take and bring off of the connection of the solenoid. All right, now quick trick question for you. What should I put on the other side of the normally open switch of the solenoid? So the single acting is going to come out and hit my limit switch, which is going to bring ground to the solenoid and activate it. So when I do that, what do I want to give to this one, which we determined extends my double acting cylinder? What do I want to give? Do I want to give power? Do I want to give ground? So when this limit switch hits, it's going to activate this solenoid, which will then close this normally open switch. So what do I want to give to the cable that I know tells this valve to extend the double acting cylinder? Do I want power? Do I want ground? I'm going to try power. Power gives it signal because the other side of it is already grounded. Does that make sense? So here's what should happen now. If I hit this button, should this double acting cylinder retract? Yeah, good job, power. I don't know if you guys are running a step behind me on the chat. If I hit this button, hopefully that double acting cylinder will retract. Right now to do nothing because I have the power off. Now I'm going to turn the power on. Hopefully that retracts. Sweet, that was cool, right? Why did it go back? That's a great question. Because the solenoid is live. You see how I got to switch those? All right, I'm going to kill power and switch things around for a second. I want to swap what's happening with this guy. So I'm going to bring him up and I'm going to swap these two things out. Let's get power again. If I hit that, nothing happens. If I hit that, everything should go back. If I hit this, What should extend, the single acting or the double acting? Single should extend until it hits the switch, and then it allows the other one to come on. Did you see that? Anybody catch that? Let's undo the switch for a minute. Let's just say he wasn't here. So if I hit and extend the single acting, notice how the double acting cylinder doesn't go. Why not? Because I didn't tell its valve to do anything. So let's go back and put our grounds back in place. Notice it immediately jumped there, right? So that should bring everything back. This bad boy should extend to hit the switch and then immediately slice. Is that good for the operator to have the second the guard clears to immediately slam, slice, move, or pick, whatever it is? It's probably a little quick, right? So what could we use to slow down that extension? If we wanted it to come out slower, what could we use? It's air, so how do we get a cylinder to go slower than it normally would with shop air? Remember our shop air is at like 80, so whenever I extend that cylinder, I get my full 80 and off she goes. How could I slow down a cylinder and get it to go out a little slower? Flow control, great job. I'm trying to find one. Give me just a second. I got about 1 million T's, I got no flow control. None. Let's see what I can find here. And I appreciate you guys hanging in there with me. I hope you've enjoyed watching me roast on live camera. The cool thing is it's probably something simple, but you look like a complete dumbass in front of the customer if you don't know what you're doing and you don't know what's going on. So I think we also learned that a live rehearsal of this would have probably been pretty smart, right? All right, so here we go. I think we got a flow control. What kind of valve is this? Flow control valve, but like what type? Like mechanically, what does it do? And Josh there was something about the flow control. We don't put it on the side putting air in. Correct, you always put it on the vent side. And why is that? Needle, very good guys. You guys are way ahead of most classes. So when it's all the way out, does that mean air can go through fully, or does that mean it's closed off and restricted? So if I undo the valve and let it all the way out, does that mean I'm letting more flow through or less flow through? If I tighten it all the way down, what's going to happen? Does that cut it off or does that let it go through? All right, so what we're going to do is we're going to attempt to slow down the double acting cylinder using the flow control valve, right? So which one of these two ports on the double acting cylinder makes the cylinder extend, and which one allows it to come back? Does the one on the left extend it, or does the one on the right extend it? So I'm on the double acting cylinder, I'm coming off my valve. Does the port on the double acting cylinder that's on the left here, the left extends, or does it retract? What actually physically happens? The air goes in this side, and what does it encounter in there? It goes into the cylinder, the tube itself. What does it bump against? It bumps up against a flat plate or a cylinder that extends out, okay? For a double acting cylinder, do I get the same force when I'm extending as when I'm retracting? Yes or no? I'll figure out how to actually answer questions. You guys can answer it in the chat in a minute. So if I extend a double acting cylinder and retract a double acting cylinder, do I get the same force extending as I do retracting? I got a bunch of yeses. Let's think about it for a second. Here's a very poor drawing of a double acting cylinder. So it's the one that's in front of us. If I put in air here, it pushes against and extends the cylinder. To get it to retract, I put air in on this side and it retracts. Are the areas that it's pushing against the same on both sides? The surface area of the plate is different. Why? What do I subtract out on the return? So I have the full area on the extension. What do I subtract out on the return? It's the area of the rod. And oftentimes you'll see that, they'll give you that information when you're buying a cylinder from Bimba, Festo, whoever. The area of the rod, and then you can begin to figure out what is the force? Like, how do I determine what the actual force is? If I wanted the force in pounds, what two things do I need to know? Pressure equal force over area, right? So how do I determine the force? Pressure is force over area, that's right. How do I figure out what the force is? Good old pressure times the area. So if the area of the rod is removed from here, I have less area to push against, which means I get a smaller force. So that's something to watch. If you're trying to do some kind of operation where you need the same force both directions, you're going to have to trick a double acting cylinder to do that or find a different way to do it, right? You're either going to have to give it a little more pressure on the return side than the other. Most of the time when you're using a double acting cylinder, you're doing whatever it is you're trying to do on the extension. Or another good spot where you might use a double acting cylinder is something that you need to know is in place and hold there. Like on a single acting cylinder, I get a spring retract, right? So if I was to lose air, then that thing would immediately retract. And that'd be bad if that was like my guard or something like that, right? If it immediately retract. That'd be really good if it was like my emergency exit. If it's an emergency exit and I lose power and it immediately retracts, good, I can get out. A double acting would be, I have to lose and vent the air for the thing to be able to move, and then I have to physically move it. Does that make sense? So that might be good for something that I want to keep in place. Maybe I'm positioning something or I'm clamping something down and I'm wanting it to stay there, especially if I lose air or shop air or power or any of those kind of things. All right, so let's keep going for a minute. We had air to everything. We had our single acting cylinder extending and hitting a switch and then allowing our double acting. We were attempting to do the flow control before I got all sidetracked. So which side of the double acting cylinder should we put the flow control on to get it to extend slower? The left side, which is the extension side, or the right side, the retraction side? Where should we put the flow control? Yeah, we're going to try to put it on the retracting side and see what happens, right? As we said, we want to control the vent. We want to know the power that we're putting out. We want to know the prime mover, the extension that we're putting out. So we want to know exactly what we're doing there, and then we'll control the backside. So let's just see what happens here. We think that we could put air in one side, bring it out the other, and then use this to restrict or close that off to make things go a little slower. Does that make sense what we're doing there? So I got to get another hose. And let's see if I can find one that's not 1,000 miles long. There we go. That one might work. All right, so there's one side. We have our air off for a minute so we won't get blasted in the face again. We'll go into our flow, and then we'll take that to the cylinder on the retract side. Now, do you guys think we should have the flow control all the way closed or all the way extended to begin with? And interestingly, this one's got a stop on it. Let me pull that back out so you guys can see it. So in very poor lighting, there's actually a stop guide right here. So you can have it go to whatever you want. If we figure out what we want our valve to be set at to get the speed we want, we can then slide this puppy down and lock it in place, and that'll hold it. That'll keep it from moving on us. Because you got to think about them on machinery, things that are shaking. This thing could move on us one way or the other. I'm going to attempt to tighten it all the way down and just see what the range is on this thing. All right, that looks like it's all the way down. So we're going to open it up as much as we can before the screw comes out. I like Peter. I don't know, do what you want exactly, right? We'll try one and then we'll try the other. That's one cool thing about lab tonight, is we're just experimenting, figuring out what the heck's going on. All right, so let's try this bad boy one more time. We're gonna go in one side. We'll come out the other to the cylinder. We're gonna move the hose so we don't smash it with our cylinder. We're gonna turn our power back on. Nothing should happen, that's good. Do you guys remember which button extended everything? Was it 2 or 3? Wasn't 2, maybe it was 3. Here we go. Oh, what's going on? What's the problem? Closed, right? Let's turn her back on. Now, what do we hear? We got an air leak right here. We didn't get this hose pushed in far enough. Oh, that's something I should probably show. Hang on. So each of these connectors, if I put the hose in, I can't pull it back out. I've got to then actuate this little grabber to get the hose back out. Now, one key when you're plumbing these things is you'd like it to be a lot more square, because it's got to get all the way down in there and seat to get it to work right without leaking. So if I have a leak, I may have a slight angled cut on a hose, which I think this is one Brandon put in to try to trick people. So we'll see if we can find, in that case, this sucker may be a little bit angled, or I may just not have it all the way down in there. All right, let's turn air back on. We still got a nice healthy air leak right there, so we don't like this flow control valve anymore. Let's check our hose and see if it's angled. Big time. Let's try a different hose. That one doesn't look too bad. Let's try it again. Still leaking like a sieve. That sucks. Maybe we can get it to work long enough to slow this thing down. Let's try that. All right, button 3 extends. Now I want to make the cylinder go slower. Do I tighten the valve or do I loosen the valve? Who knows with it leaking like that, right? Check that out. I've got it so tight that I won't let any air through. Pretty cool, huh? Yeah, bad flow control. Try it again. Here we go. Extend, nice and slow, and smash, grab, do whatever it is we're trying to do. And I could adjust that speed to get what we want. One key thing, if you notice, pneumatics are not precise, right? I couldn't precisely tell you what that speed is, and I probably, other than getting to full extension or full retraction, I probably couldn't tell you exactly where it is or how far it's going to go until I bottom out. So that's one thing to remember in pneumatics. It's great for popping things in place, knocking things out of the way. You'll see it a lot on assembly lines where you're just trying to pick, place, move skip something to the side, knock something in a bin, that kind of thing. Nice and slow. All right. So let's go back. Let's see if we can figure out what was happening with our single acting valve and why we're not getting it to return when the air goes out. We're not venting that valve somehow, right? Josh says, do we lubricate the piston for smoother movement? I didn't mention that before. I may have in the other video. Shop air's normally got a little bit of oil running in it so that you don't rust out your lines. So there's going to be a little bit of lubrication in the system. A lot of times you'll see an oil or filter regulator. In this case, no, we're not gonna lubricate the valve itself because it's probably got a bearing on the end that's already set up for that, right? I introduced too much oil, I introduced a problem with that bearing. So that should be pretty well sealed, otherwise I got air going through there, right? So to get it to go smoother, I probably need a less crappy flow control valve, right? For now, I'm going to take the We Hate flow control valve out for a minute. And let's go back to what our initial problem was we're having, which is there's something we don't understand on this valve to get the single acting cylinder to work. Because it's supposed to retract right there, right? So how do we get it to retract? When we're hitting this button, it's retracting. My guess is we've probably got to vent one of the other ports. Why don't we try a different valve? Would this do anything differently? Take out the plug, Jared. You want to try that? Remember what happened? I got air blowing in my face. I got to plug one of the sides, right? My guess is one of these is the one that we need to vent and have open. Yeah, the plug is there for a reason. That's right. I say for fun we try our other valve. What kind is this one? So you guys think this valve would work? I'm gonna kill my power and I've turned my air off. We're gonna try to do a little replumbing here. So we're gonna take this valve completely out. Right now, the only thing he's connected to is the single acting cylinder. So we're gonna kill off that hose. We're gonna pull this whole bad boy off the board. Let's see if it's the same connector type. Looks like it. Now, before we do anything, we remember how we have him wired. He's to one side of the switch or the other. So one easy thing we could do right now is turn our power back on and hit our two buttons and see what happens with our valve. See which light comes on. But you know what? Let's just have some fun. Let's go on and give it air and just see what the heck happens. How about that? That way you guys can get some amusement out of watching me get smacked in the face with a hose or something again. Might be fun. All right, so I'm giving air to the valve. I got everything wired up like I had before, and I'm only coming out of 2 and going to the single acting cylinder. Let's see what the heck happens. If I turn on air, hey, I don't have air pouring out of port 4. That's cool. That's better than we had before. If I turn on the power, if I hit button 3, hey, look at that. Boom, right? What's happening there? Remember, this side extends. So how do I keep air from coming out the other side when I hit that button? What can I do? I go to my control cable and I remove the one that's attached to that button. Boom. Let's see what happens. Hey, now I don't get air in my face. That's awesome. It's less loud. Let's try again. I'm going to hit the button. I extend. When I hit my limit switch, my second cylinder extends. That's kind of neat. When I hit this button, what's going to happen? I return my cylinder. All right. That was our intro lab. I think you guys got a nice little view of A, work from a drawing, B, figure out and learn your valve before you get in front of a whole bunch of people live so they don't clown you as bad. C, keep working on it. You know what these things are. Work your way through and logically, one point at a time, figure out what's going on. We decided we needed a different valve in that spot because we didn't understand the valve that's here. So for our homework, we might go figure out what's going on with this valve and why the plug didn't work the way we thought it did. My guess is we've probably got the wrong port plugged or unplugged or not plugged and doesn't have a muffler on the backside. Hit me with big questions right now. Other than, why didn't you do a better job tonight? What questions you guys got? Or what do you want to do next? We got a few minutes. We could put a whole nother cylinder up there if you want. What do you guys want to do next? Call it a night and make it beer 30? What I would like you guys to do is, you have the very last lab, right? The one that says pneumatic and electric. It says press button B1, cylinder A extends. When A is fully extended, cylinder B extends at an adjustable rate. Didn't we just do those first two things? So our button that we had here extends, we could call this button B1, it extends cylinder A, and when cylinder A is fully extended, then cylinder B goes. When A is fully extended and B is pressed, cylinder C extends. So in that case, what would we use off of A to tell cylinder C to extend? Let's see, you could put a check valve to see what the pressure is on the flow control valve. A check valve restricts flow one way or the other, right? Anyway, back to where we were. When A is fully extended and button B is pressed, cylinder C extends. How could we make that happen? Right, we could use the limit switch to know when cylinder A extended, but then how do we get button B to work? Because if it extends, see right now when it hits that switch, see even if my cylinder doesn't hit it, if that switch energized, that cylinder extends out, right? See? That could be bad. What if I want that to be in place and the operator then to hit the button to make it go? Button B is in series with the limit, that's right. I would put it there so that I not only have to get that signal, I have to get the next button signal. So that's really all we would need to do to handle this third bullet here. When A is fully extended, so the limit switch would tell us it's fully extended, and B is pressed, then cylinder C would extend. So we could have another valve, wire all that up, where when that happened, and we hit a button, we extended another cylinder. When we press button B3, all cylinders retract. How would we do that? Like right now, I have this cylinder not retracted. The only way to get him to track is to get that button to do something, right? If I had this cylinder down here extended, how would I get them all to retract? Well, I could vent the single actin, Chris, but the double actins, I've got to give air to the other side to get them to retract, right? Releasing any button does not change the state of the cylinders. That's an interesting one, right? So when we have something extend, we want it to stay extended. And only the one button makes them all come back. So what I'd like you guys to do, Peter, and that was your question, I'd like you guys to sketch up the electrical and schematic for this using some of the things you learned here, right? How would you do that third button to get everything to come back? What would it look like? Where would you put it? That make sense? All right, any other big questions? So that was our homework. Most of you are already done with that, right? And you've already sent in the drawing for the big guy? Is that correct? No, that's good if it's already in, because we really don't want to overload Jay any more than we need to, right? And I think since we've had so much craziness this semester, I know you guys have got a lot going on in your other classes. The main reason for this lab was to give you guys some experience and some hands-on of getting to make a fool out of yourself like I did on live stream, right? Where you'd begin to figure out what these things do. And the thing that you take from it is, hey, I need to learn these and know what the difference in these valves are and what's going to work and what's not going to work. And then I need to go get my hands dirty and get in the shop. So I've told you guys before, wherever your first jobs are, try to make sure they're in the field or in the shop or in a manufacturing plant, and go volunteer to work in the tech lab. Go try to get the guys to let you build the panels and do all the wiring, because hopefully your wiring looks better than mine does tonight, because that's a massive spaghetti monster. Imagine if you had to come in and debug while something wasn't working or fix a part. Easiest way to shut the compressor off is to kill the power. No, I think I'm going to make your homework really easy for you guys tonight. You guys have done really well this semester. Your Ross work was awesome. Hopefully you got everything in to Jay, and hopefully you got out of that Ross is pretty cool and something that you got to put a lot of time in to figure out what's going on. In the MCU labs, you got some experience wiring stuff and letting the smoke out of things and all that kind of stuff. Here in the lab, we got a little look into pneumatics and electrical solenoid controls. All those things are cool. The important points are, anytime you're doing any work here, think about what you could actually use this for in the real world. You know, we talked about guards and choppers and all those kind of things. Don't be afraid to make some mistakes. Just make sure you keep everybody safe. And then anyway, so as a final for your homework, here's what I got with you guys. So I want everybody who's still on here and has suffered through this extremely well lit and incredibly well choreographed video, everybody's still on here. I want you to think for a minute. Think about, was there someone in your life that has helped you get to this point? Someone that without them, without their guidance, their help, or whatever it might have been, their shoulder, whatever it was, that you wouldn't be where you are without them. And if you can think of somebody and you don't mind sharing, pop their name in the chat real quick, right? Got a couple people popping up, right? Someone who really made a difference in your life and really changed things, okay? Now here's kind of what I'm going to challenge you guys with. I'm going to continue asking this question over the years that I'm here. And what I want is, I want to start hearing your names. If you were in this lab this semester, I hope a year, 2 years down the road, I begin to hear your name as someone who made a difference and changed somebody's life in this program, right? Because I want you to think about, what would this place be like if every time you walk down the hall and everybody you ever saw was like, what can I do to help you? What can I do for you? You know, are you doing okay today? How are things, right? I want you to think about what this place would be like. Well, the only way to start that is to start. So that's what I'm challenging you guys with, is I want you to start. I want you to start giving back and helping others. I want the 3-year out graduate helping the senior who's trying to find a job, helping the junior who's working on a project. And, you know, all of us have to help the freshmen. I mean, dear Lord, we got to help the freshmen. Give them some experience, get them in there, show them what's going on, tell them it's going to be okay, and they'll make it through, right? The other big part of this is, as you get out and you graduate, and I know you're going to get hit for money and all the other crap that the alumni associations and things to do. What I really want you guys to do is think about, what kind of projects could you send back for us? What kind of cool senior projects could I get my company to send back? What are some things that I wish I had had that now I can send back and help the people coming behind me? Because one of the coolest things will be one day when somebody from KSU helps put, you know, a lander on Mars. That makes every single one of you and every single one of us look better, right? If KSU and the mechatronics department is known for doing incredible stuff, that follows you for the next 30 years of your career. Oh man, you're a KSU guy? Hey, I saw they did such and such. So the only way to get that help is to do what you wish the people ahead of you had done, right? So I hope that makes sense to everybody. I'm asking you to be a part of the program. I'm asking you to get involved on Discord. If you want some just real straight up homework, get involved on Discord for the next couple of semesters. Even if you're an alumni, get out there, let the kids know what's going on, tell everybody what's coming behind you, help people with labs and experience and things that you learned and all that kind of stuff. So that's really, there's your homework, Peter. If you want something to do for me, get involved on Discord, get involved with each other, help each other out, look for the student who's struggling and go see if you can figure it out. You never really learn anything until you teach it for the first time. So I really, really hope you guys do that for me and for us and for all of us to make this place better. So I really appreciate you guys suffering through this fantastic video. I appreciate you suffering through the semester. I wish it had gone a lot better in the fact that I wish you guys had gotten in here and been able to get your hands on some of this stuff. If any of you guys are not graduating this semester and you're around next, keep an eye out for when we do this lab next semester and come down here and help us out. Might be fun. You can get your hands on some of this stuff and see if you can figure out why I couldn't get the stupid valve to work right and look like a complete dummy on camera, right? So get involved, be a part of it. That's really your homework, Peter. I'm going to put all the grades and things together. If you owe Jay anything, you know, get it to him immediately, send it directly. I think everybody's already put most everything in. I'll get the grades to Bacchus. I'm not sure what he's going to do with them from there. Wish you guys well. Any of you guys that are graduating, if you need me, make sure you connect with me on LinkedIn and let me know if there's anything I can help you guys with. All that makes sense? I got an okay from Peter, so that's really all I needed for the whole night, right? All right, now, 2 things I got to do. What are they? Yeah, you could email it to me, right, Jay? Because you guys have hooked Jay up with like 12 different ways of putting stuff to him. I think he even got some stuff like mailed to him in the postal service. What are the 2 things I need to do before I get out of here? What are they? What are the 2 things I got to do? I got to clean up, right? And at the end, I got to make a little note. Hey, what I learned tonight, what could I do to get better? So those are the 2 things. I think we're out at that point. Hopefully everybody had fun. I'll leave it streaming for a few minutes so you guys can chat back and forth and watch me clean up and put everything away. Hope everybody has a great night. Anybody that wasn't around on Friday, hopefully Jay remembered to record this so that we can all laugh at it years from now and have a good time with it. So I enjoyed having you guys this semester, and I appreciate the opportunity to spend some time with you. Thanks. And with that, we're out. Still works. First thing we do is kill the power. If you guys are still here, I'm questioning your sanity or how bad lockdown is and how boring it actually is. If anybody has any questions about any of the stuff we just did, hit me up. You can hit me in chat for another minute or two, or pop me an email. And again, if you haven't connected with me on LinkedIn, that's probably something you should do immediately. Yeah, Queen, if you're the one that just happened to wander by and find us, I hope you enjoyed yourself and had a great and entertaining evening. That's how bad lockdown is, that watching some random dude put cylinders together on a board is more entertainment than we've had for a while. You guys that are still here, what do you think is going to happen? Are they going to open up the world here in a couple weeks, or are we going to be stuck till summer or after that? Because I'm supposed to go to Puerto Rico in June. I wonder if I'm going to be able to make it. Any of you guys that end up out in the industry, if you're talking to the Motion Rep or the Parker Hannifin guy or Bimba or any of the other manufacturers, see if you can get us some more equipment for these boards. That would be absolutely awesome. Here's an interesting one. I got air in the line. It's not letting me disconnect at the compressor, so I need to vent it out. That's why you wear your safety glasses. Actually, on the compressor, there's a vent, so that'll work faster. Now I can unhook the hose. All right, hope everybody had fun. I have no idea why you're still here. I'm ending the stream. See you guys later.